All right, welcome to the notes for H3-7, multiplying and dividing radicals in binomials. So getting started here, there is a warm-up. We do the warm-up in class. This is kind of based on the previous section. In this particular warm-up, it's asking you to multiply the square root of 3x by the binomial that is made up of the square root of 6x plus the square root of 2x to the third. So let's just take this square root of 3x and let's just distribute it through. Keeping in mind now we're multiplying, two terms where all of our values are underneath the square root. So we can actually multiply those. What we're going to end up with there when we do the 3x times the 6x is the square root of 18x squared. And when we do the square root of 3x times the square root of 2x to the third, we're going to end up with the square root of 6x to the fourth. And then your goal here is just to simplify them down and see if you can combine it in the end. Remember, right now we can't add them together because they're not like radicals. But we know that the square root of 18 here, the square root of 18 is going to end up being 3 radical 2. So that gives us a 3 radical 2. And then our square root of x squared is going to give us just an x. So we have times an x. And then we have plus. Remember, this over here, this is still like a product, right? It's still being multiplied times each other. And we'll simplify what it looks like here in a second. Over here, the square root of 6, we can't take the square root of 6, so we're going to leave it under the radical. And then we know that any even exponent is a perfect square. So the square root of x to the fourth here, we're going to say is x squared. And we're not worrying about absolute value or the positives or negatives. I'm thinking about it like it's the principal square root. And now we're going to take it here and just clean it up. This would be 3x times the square root of 2 plus x squared times the square root of 6. Because they don't have like radicals, that's as far as we can go. All right, so let's look here at our first examples, multiplying binomials. So we're just multiplying binomials, and then it says simplify the following expressions by multiplying the binomials. Okay, so pretty simple directions there. Let's take this here. Remember, you're multiplying a binomial times a binomial, so you can, use your generic rectangle if you'd like to. Or you could take it, you have your horizontal method, your vertical method, or you could do, the FOIL method there. Any one of those will work for you. I'm going to go ahead and just FOIL it out there. I'm going to do 4 radical 2 times 4 radical 2. So that should give me 4 times 4 is 16. And radical 2 times radical 2 is going to give me 2. So I have 16 times 2 is my first term. The outer terms, when we multiply it there, 4 radical 2 times negative 7 should give me negative 28 radical 2. When I do my inner terms here, 7 times 4 radical 2, that should give me a positive 28 radical 2. And then when I do the 7 times negative 7, that should give me a negative 49. Now we just look to take it here and simplify and combine like terms. 16 times 2 we know is 32. Our two middle terms, negative 28 radical 2 and positive 28 radical 2, are going to end up canceling each other out. And then we'll bring down that minus 49 here. And when we simplify it, we should get negative 17 as our simplified answer. Letter B. We have the quantity of 3 radical 5 plus 4, and that's being squared. So the biggest mistake that happens on this one is students will forget that this is actually a binomial times a binomial. You cannot just take this and distribute this 2 through. You can't just do that, right? You have to do exactly what you did on that last one. So if we're looking at it here, we could say 3 radical 5 times 3 radical 5. Well, 3 times 3 is going to be 9. Radical 5 times radical 5 is going to be 5. So we have a 9 times a 5. If we've got here the second term, 3 radical 5 times 4 is going to be 12 radical 5. And then we're going to go into our inner terms, 4 times 3 radical 5, also 12 radical 5. And then 4 times 4 is going to give us 16. When we go ahead and multiply our 9 and 5, that should give us 45, plus the 12 radical 5, and the 12 radical 5 should give us 24 radical 5. And then we have our plus 16. Take it there, and we can add those like terms together. 45 and 16 should give us 61 plus 24 radical 5. And that is as far as we can go right there. If you'd like to, you could take this next one here, pause the video, try to work it out, and see if you get the same thing I do when you replay it. So with this one here, we're going to do the same thing, just now we have all different kinds of expressions in here. So we're going to do 3 radical 5 times our 2, which is going to give us 6 radical 5. We're going to do 3 radical 5 times radical 3, which should give us a 3 radical 15. Now we're going to take it here and do our inner term. So negative 2, remember, take that negative with it, times 2 would be minus 4 radical 3. And then negative 2 radical 3 times radical 3 is going to be like so think about negative 2 radical 3 times a radical 3 is the same thing as a negative 2 radical 9, or negative 2 times 3, which is going to give you that negative 6. So I'll put minus 6 here. When you look at each of these terms here, right, we've got a 5, we've got a 15, and we've got a 3. Although they are, all factors of 15 there, none of them contain any perfect square factors. So this answer, although long, is actually our final answer. We have 6 radical 5 plus 3 radical 15 minus 4 radical 3 minus 6. All right, let's move on to the second section. Example 2. Binomials divided by monomials. So simplify the expressions, be sure to rationalize the denominator. Okay, so a key part of this here is going to be thinking about rationalizing the denominator. Okay, well, when we look at this first problem, we have 2 plus radical 3 divided by radical 7. Okay, at this point in time in our math careers here, we do not like to leave irrational numbers. Remember, irrational numbers are numbers that are non-terminating, non-repeating decimals. So we don't want to have a non-terminating, non-repeating decimal in our denominator. So what we're going to do here is, there's a couple approaches that can be taken. We could take this and look to say, hey, we could split it, just like we did with our, when we were simplifying our answers, when we were solving quadratics, we'd say 2 over radical 7 plus a radical 3 over radical 7. Okay, but really, neither of those simplifies. So that's not really going to do much for us. So we'll come back to that here in just a second. We're not going to lose track of it here. But what I'm going to do here is I'm going to take this here, and I'm going to get rid of my square root. Think about, how do you get rid of a square root? Usually we square it, right? Usually we square something. But if I take a fraction, let's say 2/3 for instance, and let's say I square the top and the bottom, I get 4/9. Is 4/9 the same thing as 2/3? Are those proportional? In this case, they're actually not, right? If I multiply 2 times 9, I get 18. If I multiply 4 by 3, I get 12. So since you can't cross multiply and get an equal value, not proportional. So we're going to have to get rid of the radical. We want to square it, but we can't actually square it. So what we're going to do here is we're going to just go ahead and multiply it by the square root of 7. If you multiply something times itself, it's like squaring it. But now if we multiply the bottom by radical 7, we can also multiply the top by radical 7. And if you think about this value here, right, the square root of 7 over the square root of 7 is really the same thing as 1. We can multiply anything times 1 and not change its value. So when we do this here, the square root of 7 times the square root of 7 is going to be the square root of 49, right? But the square root of 49 is really just 7. So now we don't have a square root in our denominator anymore. And what we're going to get here on the top is we're going to have to take our square root of 7 and distribute it through the binomial. So we're going to say radical 7 times 2 is 2 radical 7. And then plus radical 3 and times radical 7 would be radical 21. So in the end here, make my fraction a little bit longer, we're going to end up with 2 radical 7 plus radical 21 all over 7. Remember, this 7's outside the radical, so we can't reduce something that's on the inside here. And that is actually going to be our final answer for this one. 2 radical 7 plus radical 21 over 7. Now, if we look back here to this one that I said we'd come back to down here, right? Since we split it apart, we can still rationalize the denominator of each of those, right? If we wanted to, here, I'm just going to spread them apart a little bit here. If we take this now and we wanted to rationalize the denominator of that first fraction, right, we'd multiply it by radical 7 over radical 7. And what we get there is 2 radical 7 over 7. And then to get rid of the radical 7 in the second fraction, we'll do, multiply by radical 7 over radical 7. And this one gives us plus radical 21 over 7, which you see is the exact same thing as the answer we had over there. It's just split apart into two fractions. We know, though, since they have a common denominator, we could rewrite it as that. So these are the same thing. So that's the correct answer. You can take either approach there. It's up to you which way you want to do it. Sometimes it pays off to split them. Sometimes it doesn't. I'll show you one here where it actually does pay off. So letter B, we have the square root of 18 minus 2 times the square root of 75 over the square root of 3. Now, one of our options could be, we could just take this and multiply, the top and the bottom by the square root of 3 like we did on the other one. Or, we can take it here and we can say the square root of 18 over the square root of 3 minus 2 radical 75 over the square root of 3. Now, the reason this one interests me here in trying it this way, when you see 3 is a factor of 18 and 3 is a factor of 75. All those numbers are under the radical. So we could use our property of radicals to think about this as saying the square root of 18 over 3 minus 2 times the square root of 75 over 3. The square root of 18 over 3 is like saying the square root of 6 minus 75 divided by 3 is going to give us 25. So we have minus 2 times the square root of 25. And then, this still simplifies a little bit more. We have the square root of 6 minus 2 times 5, which is going to give us the square root of 6 minus 10. That is our simplified answer on that one. Okay, now, real quick here, I already wrote down this definition, so you can pause the video and write this down if you need to. But this is a very, very important one here. It's conjugate, okay? The conjugate we can get by switching only the middle sign to create a pair of binomials that when multiplied has a product that is a difference of squares. For instance, here, if I had A plus B was a binomial that was given to me, if I want to create its conjugate, the conjugate for A plus B would be A minus B. In which case, when I multiply those, we know that that gives us A squared minus B squared. Okay, so if I gave you one here, let's look at, what if I had given you, let's say, the square root of 2 minus 3. Our conjugate to that would be the square root of 2 plus 3. Right? So the only difference between them is that middle sign. So when we take this here, and I were to multiply this out, and I'll go ahead and just FOIL the whole thing out here. When I do my radical 2 times my radical 2, I get 2. When I do radical 2 times positive 3, I get plus 3 radical 2. When we do negative radical 3 times positive radical 2, we get minus 3 radical 2. And then negative 3 times positive 3 is going to give us minus 9. So these middle terms, because it's a difference of squares, are always going to end up canceling out. This is just like number 1, the very first example up above. So what we're really left with is 2 minus 9, which gives us negative 7 there. The thing that's really nice about this here is there's no more radicals in it. So we're going to use these conjugates to help us rationalize our denominators in the problems ahead. So let's move on to the next one. Oops, let me clear that out. All right. So example 3 says now we are going to talk about dividing binomials that contain radicals. So to rationalize our denominator here, okay, we have a binomial in the denominator. Okay, so we have a binomial in the denominator. Okay, that's really important there. The last ones, we just had monomials in the denominator. So in order to rationalize the denominator here, okay, I'm going to have to take it and multiply it by the conjugate of the denominator. I'm going to write that on here. You should write it on your paper too. We're not multiplying by the conjugate of the numerator. It's only of the denominator. Okay, so our conjugate of our denominator here on letter A is going to be, since we have 2 minus radical 3, we're going to multiply it by 2 plus radical 3. But if we do that to the denominator, we have to keep it proportional and multiply that times the top as well. So what we should end up with here, right, when we do this here, remember this is going to be like an a squared minus b squared scenario. So we should end up with 2 squared minus radical 3 squared. Now if you need to take and just FOIL it out to understand what I'm doing there, go ahead and do that. On the top, we still have 4 times the quantity of 2 plus radical 3. So let's simplify this, see what we get. On the top, 4 times 2 is 8. 4 times radical 3 is 4 radical 3. On the bottom, let me straighten that out a little bit. There we go. 2 squared is 4, minus radical 3 times radical 3 is 3. So we have 4 minus 3, which is going to give us just 1. Right, so we're going to end up with, actually I'll write it down here, 8 plus 4 radical 3. And since it's over 1, really, we don't even need that 1. You could just say 8 plus 4 radical 3. Okay, let's look at the second one now. Now you have a binomial on the top and on the bottom. So when we're looking to multiply by the conjugate here, we're going to multiply by the conjugate of, remember, the denominator. So we're going to multiply 5 plus radical 2. If we do that on the bottom, we'll do it on the top. And now when we take it here and we FOIL it all out, remember the top is a binomial, a binomial times a binomial. This one we'd have to do 4 times 5 is 20. 4 times radical 2 would be plus 4 radical 2. Radical 2 times 5 would be plus 5 radical 2. And then radical 2 times radical 2 would give us radical 4, which would be just 2. And on the bottom, you know the middle two terms are going to cancel out, so all we need to do is think about the first terms being multiplied. So that'd be like 5 squared minus radical 2 squared. Let's clean it up a bit here. So on the top, we have 22 plus 9 radical 2. On the bottom, we've got 25 minus 2. So we completely simplify as best we can. We should have 22 plus 9 radical 2 over 23. And that would be our final answer for this one, because when you look at it here, right, 23 and 22 wouldn't reduce, so we don't need to split the fractions, and 9 and 23 wouldn't reduce either. Okay, so just a couple more here and we're just about finished. Example 4 says, show by substitution that 1 plus radical 2 over 2 and 1 minus radical 2 over 2 are roots of 2x squared minus 4x plus 1 equals 0. All right, so remember when we're thinking about roots here, let's see here, let's move this up just a little bit. Remember, we're talking about roots. Roots are x-intercepts. So whenever you take something there and you find its roots, it's like you're basically solving for x when y is 0. Remember, this is when y is equal to 0. So if these are actually roots or solutions, if we take them and plug it back in there, it should make a true statement. So I'm going to take just this first one, 1 plus radical 2 over 2, and I'm going to plug it in. So we're going to say here 2 times the quantity of 1 plus radical 2 over 2. That quantity is squared minus 4 times 1 plus radical 2 over 2. And then plus 1, this whole thing should equal 0. Now I know that's really easy to type it in on the calculator and do it. So because we're practicing, simplifying expressions with radicals in them, probably not going to be able to use the calculator when you're doing your assessment with this one. After you prove to me you can do it the rest of the year, you can use the calculator all you want. But for now, you need to show me that you can work with radicals. So the first thing here, remember, we're going to use our order of operations to help simplify this. So we need to think about this 1 plus radical 2 over 2 squared. Right, so you need to FOIL that out. So when you do that, we should get 1 plus radical 2 over 2 plus radical 2 over 2 plus, now when we do this radical 2 over 2 times radical 2 over 2, the square root of 2 times the square root of 2 is going to give us a 2. And then, 2 times 2 on the bottom should give us a 4. So that's 2/4, but, if we can reduce it, let's just go ahead there and put in there then, same thing as 1/2. Now that is all still being multiplied by 2. I didn't simplify it and put it all together because I don't really have to if I look ahead at what could happen for us here. Now the next part here, I'm going to take it and go ahead and just distribute my 4 through here. So negative 4 times 1 is negative 4. And then negative 4 times radical 2, right, if you think about it, negative 4 times the square root of 2, and that's still over 2. We could reduce that and make that minus 2 radical 2. And then we have plus 1 equals 0. Now let's just go ahead and distribute this 2 through. Why? Because look under here, our denominators are all 2's over here for 3 out of those 4 terms. This should help us to simplify it much more quickly. So 2 times 1 is 2. 2 times radical 2 over 2 is going to be plus radical 2. Same thing on the next one. And then 2 times 1/2 is going to give us 1. And then we'll just bring down everything else. And when we take these and combine them, we have a radical 2 plus a radical 2, which is 2 radical 2. And then we're going to take away 2 radical 2. That should basically cancel all of those out. And then we're left with 2 plus 1 minus 4 plus 1 should equal 0. Well, 2 plus 1 is 3. We have 3 minus 4 plus 1 right? So 3 minus 4 here is negative 1, plus 1 gives us 0, and 0 equals 0. So since that's a true statement, we know that that is going to be a root. So I'll let you go ahead and try this one here just to be sure that it works as well. I'm going to move on here to example 5. It says, use the Pythagorean theorem to find the value of x. So we've got this right triangle here, and the hypotenuse is x, and then we have one leg that's 4 plus radical 2, and we have one leg that is 4 minus radical 2. So if we look to set up our Pythagorean theorem here, our a squared plus b squared equals c squared. Okay, let's take it here. We'll call this side side A, we'll call this one side B, and this obviously has to be C. So we'll say here 4 minus radical 2 squared plus 4 plus the square root of 2 squared is equal to x squared. Now here's where I would encourage you to pause the video and try to work this out and then come back to it and see if you get the same answer I get. All right, I'm going to work this out here. Hopefully you're done, you've paused it, worked it out, and you're checking it now. When we FOIL this out, remember we're squaring a binomial, so we're going to have to FOIL it. So what you should get when you do that is you should have 4 minus radical 2 times 4 minus radical 2 would be 16 minus 4 radical 2 and then minus another 4 radical 2, so minus 8 radical 2. And then the negative radical 2 times the negative radical 2 should be like plus 2. Then we'll bring down our plus sign here. And we're going to do the same thing with this one. Now, because, the only difference between these is, oops, I forgot something there, didn't I? 4 plus radical 2. Because the only difference between those is that middle sign. When you FOIL this out, you should get almost the exact same thing, except your middle term should be a positive 8 radical 2 plus 2. And remember, I skipped over a couple steps there because I know what I'm doing. If you got stuck there, then make sure you mark that and come in and ask a question about it. And now we're just looking to combine the like terms. Well, we have a negative 8 radical 2 and a positive 8 radical 2 are going to cancel out. And then we've got 16 plus 2 is 18. And another 16 plus 2 is 18. 18 plus 18 should give us 36. And then when we take our square root of each side here, we should get x is going to equal positive or negative 6. However, negative 6 wouldn't make sense for the length of this triangle here, so we're going to throw that answer out and stick with just the positive one here. So x is equal to 6. And that is the end of these notes. If you have questions, please make sure you bring them to class. Otherwise, thank you for watching. Hopefully it made sense.